Okay, welcome to this video about solving equations containing fractions. We're going to learn two procedures today. One of them is fairly simple, one's a little bit more involved. The simple one you're probably familiar with already. It's referred to as cross multiplication, and it is applicable whenever you have an equation consisting of a fraction on the left and a fraction on the right. Just one fraction on each side. Okay, if you have that, what you're going to do is you're going to cross multiply. In other words, you multiply across the equal sign diagonally, and whatever you get when you multiply, you write that, 4x in this case, on the left-hand side of the equal sign, and then you multiply on the other diagonal, 2 times 12 on the other side. So that would be 4x equals 24, and then you can continue solving to get x is 6. Okay? Really the only complication with cross multiplication is you got to be careful if you have more complicated expressions like x plus 6. What I'd recommend that you do is you always put parentheses around there so that you can remember that when you multiply this, it's 4 times the whole quantity, x plus 6 equals 2 times 16. Now from here there's a couple ways you can go. You could distribute, which is not a bad thing to do. That would be 4x plus 24 equals 32, and then you could continue to solve. 4x equals 8, so therefore x equals 2, right? Or at this stage you could divide by 4 first if you want, right? The entire thing is multiplied by 4, so it's legal to divide by 4 at this point. And then you just have 2 times 16, which is 4 times 4, over 4, and that means one of the 4's gets to cancel out there. And you have x plus 6 equals 2 times 4, which is 8. So that keeps the numbers a little smaller. Either way is fine, whichever way you prefer. But the main thing is that you multiply across the equal sign diagonally and put the results on either side of the equal sign. Okay, give this one a try. You can pause the video and unpause it when you're ready. Okay, so the solution here is 8 times 3x minus 2 equals 6 times 2x. Now I'm going to do this one with distribution. 24x minus 16 equals 12x. And then let's see, subtract 12x from both sides to get 12x minus 16 equals 0, and then add 16 to both sides to get 12x equals 16. 12x equals 16. Then you would divide both sides by 12 and get x is 16 over 12, which is the same as 4 times 4 over 3 times 4, which means that fraction simplifies to 4/3. Now, one thing you should always do, especially if you have an x in the denominator of fractions, is whenever you have an answer, you should double check to make sure that plugging it in wouldn't cause a 0 in any of the denominators, because that would make the equation undefined. It looks like we're okay here, right? Even if I plug a 4/3 in to the 3x minus 2, I would have, let's see, 12 minus 2 would be 10. So it looks like we're fine. Okay. Now how do we handle this this situation where I don't have a single fraction on both sides? I have maybe 2 fractions on one side. So you can go for common denominators, but I'm going to give you a little bit longer, more writing style procedure, but this one will work no matter how complicated the things get. So what we're going to do is we're going to factor, if necessary, any denominators, and then we're going to make a list of all of the factors that are in any denominator. So in this one right here, there's a 2 and there's a 3. Then what we're going to do is we're going to rewrite the equation, but we're going to multiply both sides of the equation by everything on the list, which means we're going to multiply every numerator by everything on the list. So I would have x times 2 times 3 over 2 plus 3x times 2 times 3 over 3 equals 18 times 2 times 3 over 3. So I just multiplied everything on the list times 2 times 3. And the reason I did that and included one of everything that was in any denominator is now if I go back, I'm going to be able to do cancellation that results in all the fractions going away in this next step. So I'd have 3 times x plus 6 times x equals 2 times 18 is 36. And that means I have 9x equals 36. And so I've got the solution x equals 4. And I should go ahead and double check to make sure, but plugging this in is only going to go on the numerator, so it's not going to change anything on the denominator, so x equals 4 is the solution here. Okay, let's take a look at a little bit more complicated example. So this one, you can try this on your own if you want. What we're going to have to do is factor this expression before we start. So I've still got 3 over x minus 4, but now I've got 3, and I can take an x out of that expression, so I have x times x minus 4 equals negative 2. All right, so my list this time is going to consist of an x and an x minus 4. And not just numbers this time, I have x's. So same procedure though. I'm going to multiply every numerator by 1 of everything on the list. 3 times x minus 4 over x times x minus 4 equals negative 2 times x minus 4. All right, then I'll go back and cancel wherever possible. So this x minus 4 cancels that one, x's cancel, x minus 4's cancel. And so what do I have? Well, I've got 3x left here, minus just a 3 equals negative 2x times x minus 4, which means I would need to distribute here. So I'd have 3x minus 3 equals negative 2x squared plus 8x. And since I have an x squared term, I want to get everything on one side and then a 0 on the other side to continue. So maybe I subtract a 3x and add a 3 to get everything to the right. So I'd have negative 2x squared plus 5x plus 3 equals 0. Let me write that again. I have negative 2x squared plus 5x minus 3 equals 0. And then, let's get rid of that negative by multiplying everything by negative 1. So I have 2x squared minus 5x plus 3 equals 0. Okay, then we would have to use our quadratic factoring techniques to go further. Things like copying a 2x here and looking for numbers that multiply and add to the two outside numbers multiplied, right, which would be a, let's see, that should be a 6, and then negative 5, is that right? Seems like I made an error here. 5, that's right, 5, negative 5, okay. And then that would be a 3. So actually I did make an error. This is a positive, this is a negative here. Okay, so I actually need this to be a negative 6, multiply to negative 6, and add to negative 5. And the right two numbers to do that are, let's see, 1 times negative 6. That adds to negative 5. So plus 1, negative 6. Dividing out common factors, we have 2x plus 1 times x minus 3 equals 0. And that means the whole thing is 0 when this factor is equal to 0, or when this factor is equal to 0. This one is x equals 3. That's a solution. And the other one, if you get, let's say, subtract a 1, 2x equals negative 1, so x is negative 1/2. That's the other solution. And if you try plugging both those numbers in, neither of those numbers makes either of these denominators negative, or sorry, 0. So we have to avoid a 0 in the denominator, so we should always check. But these are both solutions. Okay, let's look at another example. Let's say we got this one. This is going to factor to x times x minus 2 here, right? So it looks like my list would contain an x and an x minus 2. So I've got, let's see, I'm going to multiply everything by 1 of everything on the list, and I'm going to use the factored version of this right here. Okay, wait a second, x minus 2. X times x minus 2, okay? Minus 1 times x minus 2 over x minus 2 equals 1 times x minus 2. All right, let's do some canceling. Looks like the x's cancel there, and the x minus 2's, just the x minus 2's there. And so what am I left with? I'm left with 2 minus x equals x times x minus 2, which is 2 minus x is x squared minus 2x. And if I add an x and I subtract a 2, I'll get x squared minus x minus 2 equals 0. Let's continue over here. X squared minus x minus 2 equals 0 if, let's see, we need two numbers that multiply to negative 2 and add to negative 1. 1 times negative 2, negative 1 times 2. Looks like it's this one, plus 1, negative 2. All right, so negative 2 and 1, right? Okay, so this could be 0, or this factor could be 0, and the whole thing would be 0. So it's x is negative 1, or x is positive 2. Okay, now let's double check to make sure those are safe to use. Hey, I can see a problem already, because if I plug a 2 in right here, I'm going to get 1 over 0. So this one is off the list. We can't use that. Let's check the other one too. If I plug a negative 1 in, this one's okay. What happens if I plug a negative 1 in here? That would be 1 plus 2, so that's okay as well. So it looks like only the x equals 2 is the problem, so this is the only solution right here. Just x equals negative 1. Okay. Do we have enough time for another one? Yes, I think we have enough time for one more example. I know I've been going fairly quickly here. It's just because I wanted to get as many as I can in. Okay, here's one more. This one's quite complicated. Take a look. See if you can factor the middle denominator. So pause the video. Try this yourself. Okay, welcome back. Here's what you should have done. This is kind of a big clue, right? If these two are a minus 1, a minus 3, and a plus 1, most likely this factors into those. A plus 1 times a minus 3, and in fact that's right. Let's just double check it. A squared, negative 3 plus 1 is negative 2. Yep, that's right. Okay, so that means my list is going to consist of an a plus 1 and an a minus 3, because that covers everything. This middle one has both of those in its pieces. So I'm going to say 3 times a plus 1 times a minus 3 over a plus 1 plus 2a plus 7, all of that multiplied by everything on the list, a minus 3 over a plus 1 times a minus 3 equals 4 times everything on the list, a plus 1, a minus 3 over a minus 3. And then go back and cancel. Okay, here we got canceling both. And this one cancels the a plus 1. So what am I left with here? I've got 3 times a minus 3 plus 2a plus 7 equals 4 times a plus 1. This is nice. We're not going to have any a squareds in here, but we do need to distribute a couple places here. So we've got 3a minus 9 plus 2a plus 7 equals 4a plus 4. Gathering, let's see, we've got 5a minus 2, right? 5a minus 2 on this side, and you have 4a plus 4. Let me subtract the 4a's. We get a minus 2 equals 4, adding 2, so a equals 6. Let's double check. Can I put a 6 in here? Yep. 6 minus 3 is okay. 6 plus 1 is okay. That's the solution. All right, so two procedures. Cross multiplication when it's a fraction equals a fraction. Make a list of all factor denominator factors and multiply all numerators by each of those things on the list so you can cancel all the fractions in the next step is the procedure for more complicated fraction expressions.